Hi, everyone. Thanks for coming back. This is going to be Ken Shoulders number 12. And today we have Ben reading for us. So we can just jump right into it. This is going to be a good one. They talk about John Hutchison and black and white EVOs and such. So I'll let Ben go ahead.
All right. EVOs as WIMPs by Ken Shoulders. EVOs appear as clusters of electrons capable of suppressing their expressed charge and mass by a measured factor of more than 1 billion below that of the same number of individual electrons. Even in their presently undeveloped state, they could qualify for what is known as astronomy as WIMPs, or weakly interacting massive particles, and thought by some to be one source of dark matter. Down to the lowest level of expressed charge measured thus far, the black or non-interactive state of EVOs can be refreshed to the white level of expressed charge and mass by application of short-term pulses of electric field. This behavior raises the hopes of awakening the black state of an EVO from an even deeper state of charge and mass suppression, perhaps obtained naturally as a WIMP by a long residence in the solitude of space. This remarkable behavior requires re-evaluation of current notions of what charge and mass really are, especially in such a highly organized state as the EVO is apparently adorned in. In any event, this state of low expressed charge provides low interactivity with normal charged matter, a hallmark of both EVOs and WIMPs. While considering this gross obfuscation of charge and mass by EVOs, using easily available techniques, one might also consider some cosmic ray-like events as being the gradual dishevelment of an energetic EVO while entering our atmosphere with the ease and penetrability of a WIMP. Only simple methods of excitation have been applied thus far, and it is likely that awakening EVOs from a very deep state of composure will require new methods not yet envisaged. If such methods are found by following the present techniques to a much more stable level of EVO existence, then the detection and energetic utilization of the cosmic WIMPs we are bathed in becomes possible, and a new and powerful energy source will be found. This extension of technology leads to more interesting and efficient interaction mechanisms by working with artificial laboratory-produced EVOs deep in a region of stability masquerading as WIMPs. Existing EVOs have very low expressed charge and mass. There are many effective electron-like structures contained within their bounds, and they are very energetic when aroused. These parameters qualify them as provisional WIMPs and heralds of dark matter until the real ones come along. Projectiles from the Dark Side by Ken Shoulders. Abstract. Visualization of homemade WIMPs, or weakly interacting massive particles, a form of dark matter, has been made possible through the work of Shoulders, Hutchinson, and
Pocanov.
Thank you. These entities are shown to be composed of EVOs recorded to black or invisible state through cancellation of their expressed charge and mass. Their utilization portends many new aspects of technology involving penetration and interrogation of previously denied regions of material, as well as detailed exploration at great distances due to their particle probe nature, thus obviating the need for inverse square laws of propagation. An even greater area of potential application lies in morphing these electronic entities into replicas of complex organic structures. Astronauts say we are being pummeled by them from all sides, pummeled from all sides by projectiles from the cosmos they have named WIMPs, an acronym for weakly interactive massive particles, a form of dark matter that passes through ordinary matter without interaction because it is not electrically charged. There is nothing very mysterious about this effect, as it is easily done in simple laboratory experiments under our control by generating WIMPs having a wide variety of characteristics. At the present time, electrons are the easiest matter form to work with, but they may not have hegemony in this area for long. Visualization of these homemade WIMPs is made manifest in widely diverse experiments shown by Shoulders, Hutchinson, and Podkletton. How do you spell it?
Podklanov.
Podklanov. There we go, which are briefly introduced below. Ken Shoulders has shown that electron clusters named EVOs, or exotic vacuum objects, are capable of being formed from simple spark apparatus that are then self-cooled and ordered enough to be passed through millimeter-thick samples of aluminium at entry velocities of only hundreds of volts, instead of the megavolts normally required for simple electrons. Images of emergent fragments in the initial EVO can be seen on particle pinhole camera images, as well as a scattered spectrum of plain electrons, sometimes organized and projected in ghostly form. John Hutchinson has produced extraordinary effects on material for many years without having an adequate description of the cause. This author analyzed Hutchinson's samples in the 90s, and although the many EVO strike marks found attested to them having been exposed to EVO sources generated in his spark apparatus, it was not clear why most of the energy released in the process seemed to come from inside the bulk metal samples. Details of the EVO entry method were not clear, but the signature of being there was made very apparent. Over time, it became unambiguously clear from the work done in Shoulders' laboratory that the metal was being penetrated at low velocity by incoming charge that had been partly neutralized by the EVO process before passing into and releasing its energy within the sample. This internal energy release mechanism adequately explained the very unusual patterns of
decrepitation. Decrepitation.
Yeah, there we go. That was found. In addition, the material was found to melt without heat. This form of dishevelment, as cold fluidization, was in accord with the other findings by Shoulders and published in his 1999 Charge Clusters in Action paper.
Eugene Podlekanov
has shown the effects of a form of WIMP projectile launching from an apparatus consisting primarily of a pulse-fed sparking gas diode using a superconductive cathode. A narrow beam-like energy form is projected forward from the apparatus and found to penetrate the walls of buildings in its path. There was some momentum transfer to measured objects along the way, as the energy form passed through, but the interaction was sufficiently weak to call the entity a gray EVO. The small angular spread of the beam is entirely consistent with being a projectile composed of an EVO having been only partially cooled by its superconductive cathode origin. From laboratory work by Shoulders, it is concluded that this partial cooling resulted from having no natural EVO cooling zone within the apparatus after launching from the cathode. The superconductive cathode was required to show the basic effort of penetration by gray EVOs, but is considered unnecessary if other cooling mechanisms are involved. EVO cooling process. Electrons extracted at very high density from a cathode operating in practically any mode, but most often by tunneling, leave with sufficient order to be classed as EVOs. Immediately after extraction, they cool themselves by intense electron emission in what the author refers to as the white mode. After a brief period of time in a tranquil or low-noise environment, they automatically enter into the black mode of existence by further consolidation. The cooling limit of this mode has not yet been ascertained, but it is sufficiently low for the EVO process to mask charge and mass enough to allow them to easily enter solid material and traverse through it as if it was very transparent. In arc welding and electrical discharge machining, EDM, there is insufficient tranquility for the cooling process to become effective enough for deep penetration, although both processes are replete with disturbed EVOs. This insertion of one material, This insertion of one material into another without modification or damage to either form effectively signals the end to thoughts of the impenetrability of matter by matter. In this mode of operation, the two matter forms coexist with a new set of rules that are largely unknown. Not even the most basic measurements, such as propagation velocity and its limits, are available. It is very likely that these new laws will not be congruent with known electromagnetic limits, but at some point in time, new laws of New laws of mobility will be known as, and devices for manipulation of dark matter, such as lenses and timed operations, will be designed and used. Reflection or deflection, test examples. Reflection or deflection of the white EVOs from EVO form have been relatively consistent with known rules for electron control through the high intensity of the EVO. Although the high intensity of the EVO induces charges in nearby electrodes to such an extent that many deviations are seen unless such an allowance is made. Using this control, it has been possible to interact two sequentially launched white EVOs by retarding the first in the series and have the second catch up with it and interact explosively, producing a brilliant flash of light in vacuum. It has also been easy to determine the charge to mass ratio of white EVOs by time of flight methods, which show them to equal that of single electrons. The velocity of a black EVO is normally clocked by indirect methods as being equal to its launching velocity before converting from the white state. The charge and mass reduction have been followed down to a limit of about 1 part in a billion below that of the initial number of electrons incorporated in the EVO. There have been no direct measurements of the temperature of the black EVO state, although indirect measurements of ordering exist by testing their ease of penetration into solids. Looking forward, in a previous paper by the author entitled Permittivity Transitions, a form of thrust production not depending on mass ejection was proposed. Essentially, it consisted of circulating electron mass around a loop in both white and black EVO form while the forms are switched 180 degrees apart in position. This propulsion as mass pumping now seems cumbersome in light of newer methods proposed by Shoulders in recent papers on EVO propulsion. A type of radar using dark matter projectiles in gray format, capable of exceedingly deep penetrations into material objects, leaves no place for anything to hide. In addition, timed interaction of multiple entities gives the opportunity for either explosive action or selective interrogation at any place within the target area. These dark projectiles could cross a galaxy with greater ease than a photon and return to tell the tale of goodbye to the inverse square law. Don't worry about our progeny finding their way home. We'll find a way for them. Interaction of specially prepared gray EVOs with complex organic structures as either a unilateral or bilateral process raises the hope of finding a high-gate electronic growth process for morphing complex EVO-like structures. Can the spirit world be very far from this?
Okay, well done.
Wow. Thank you, Ben. That was awesome. One of the things that came to mind is the temperature of them or him talking about trying to measure the temperature of a black EVO versus a white one. I don't know if that's been done yet. These papers are almost 20 years old, right? So there's probably a lot of work that's already been done. Yeah. Does anyone have any comments or?
Let's go back to the top.
When was Shoulders' ultimate paper on these topics?
When was
this one? 2006.
Yeah, these were 2006. Most of the papers that I have are around that time, as a matter of fact. Yeah. And I want to thank Chris Beskar again for giving me this information. And I actually talked to him yesterday. I was texting him, and we're going to set up another interview with Lacey and I and Chris in the near future here in March sometime. So that's kind of exciting. Yeah.
One thing I noticed about weakly WIMPs or weakly interacting massive particles and dark matter, I know when I was studying particle physics, they were looking at weakly interacting massive particles or dark matter to try and explain. I mean, in dark matter, I think one of the reasons for dark matter was to explain how the galaxy arms were held together and didn't wind up on themselves, and also the fact that they calculated that the amount of mass in the universe is much more than what they can detect with the telescopes when they count all the stars and the galaxies. And then
Yeah.
weakly interacting massive particles were also, they're talking about, some lectures were as particles that could be maybe some candidates for dark matter and things like that. They haven't actually detected dark matter. They've done a number of experiments. They've got
Aren't,
a number of big
Right.
experiments
I
trying to
think
go on.
so. Yeah.
um,
So WIMPs are like muons and leptons and
yeah,
bosons
I was about to
like
say
that.
that they're like muons, and muon detection was used to find the new chambers in the Great Pyramid at Giza. And in
Yeah.
fact, Carmen was actually there when they did it. She was running around helping everyone set those. They're kind of like photographic plates or X-ray kind of plates that detect the muons coming in, and they found a chamber above the Grand Gallery that's 111 feet long, which is really interesting.
I'm not quite sure if it's
And
the same as the weak interaction. Here, Wikipedia, this is in terms of conventional physics. Weakly interacting massive particles are hypothetical particles that are one of the proposed candidates for dark matter. So the weak interaction is the Z, and the Z particle and the W particle is the for the weak interaction in the conventional model. But the weakly interacting massive particle, they're particles that are weakly interacting, so they can't detect them. They can't. They're trying to find ways of detecting. They can't detect them easily. That's why they're called weakly interact, because they don't. They interact very weakly,
yeah,
and they are proposed candidates for dark, because they haven't found dark matter. They've got lots of different candidates. They've got these big experiments full of washing up liquid or whatever to try and detect particles and what have you, try and find it, because they're just going by the. They say that there's much more mass and energy in the universe than they can detect. They can detect with the telescopes in terms of observing stars and galaxies. They think there's much, and also the Milky Way and other galaxies. They can't understand how the galaxy arms don't wind up on themselves.
yeah.
So
Isn't
they created dark matter to try and hold the galaxy in place. Well, Paul was saying that the galactic superwave in subquantum kinetics, the mother star and the galactic superwaves, they push the
yeah,
spiral arms out. So you don't need dark matter, because the galactic superwave, when it erupts every 12,000 years, it pushes the spiral arms of the galaxy out with the action of the wave. Anyway,
and
that's that. Gone.
yeah,
Didn't Bob suggest a theory that dark matter? I think it was Bob. Anyway, I probably shouldn't attribute it, but he suggested that complex consciousness might be detected as as dark matter or something like that. But
yeah. And I think what's being implied here is that the WIMPs are basically these black EVOs that are in that state essentially, and yeah, they're able to go through anything essentially, right? So much more study needs to be done on all of this stuff for sure, and I think that's something that's going to happen in the future. As a matter of fact, more work on Ken Shoulder's research essentially in a laboratory type situation. Yeah, definitely.
And he was
Does
sort of
anyone?
coming at this from a sort of like alternative physics side. So he was developing his own ideas. He was wiping the slate clean as far as conventional physics goes, and just recording what he was observing in his own experiments.
Yep, yep.
So
He
so
definitely
he
was.
wasn't being guided by the conventional model
No,
in a
no,
way,
and
but he was using some of it, but also being open to his own ideas about EVOs, and dark
yep,
matter kind of thing.
yep. Well, that's great. If does anyone else have any questions or comments? If not, we can stop the
Yeah.
recording.
So again, I bring this up in almost every meeting just because there are some pretty crucial connections, and I think it's worth a look. So if you look at a lot of these different technologies, as you collapse towards 0 point, it seems like that's where the real release in energy is, in terms of, and a lot of these different technologies, they're all getting at that in different ways. And specifically, since this is around Paul Laviolette and some of his findings, and he did fully recognize the work of Randy Mills, I got to keep bringing this up, and it's absolutely worth a look if you haven't checked out Brilliant Light Power's website. Now, I don't fully subscribe to all his theory. I just think that since he is actively working and puts out a ton of patents, and he seems to have a pretty viable technology that Paul's pointed to, specifically when it comes to these EVOs and dark matter, the real theory that Randy puts out there is that these so-called hydrinos, which is just a lower energy state of hydrogen, so instead of sitting at n equals 1 orbital, there's many fractional orbitals, which is basically just looking at that fine structure constant of the atom. And even Paul predicted that you could have a more collapsed state, and the amount of energy he's getting out of it is stupendous. And there's a lot of data backing that up. And if you look at some of these articles, I mean, if you go out on our website and even just look at January 7th of this year, the title of this on latest news: hydrogen atom decay and production cycle drive the space-time expansion contraction cycle of the universe. And I won't read the whole thing, but he just says hydrogen is the quote unquote phoenix particle of the universe. Recycling of matter or energy in the universe occurs in an oscillatory cycle wherein matter converts to energy primarily through hydrogen atom decay via hydrino pathway. So this is fairly well supported, and I do think I think there's something to be said there that, if hydrogen is the most predominant element found in the universe, it only makes sense that if there is this dark matter that supposedly takes up a large fraction of what we can't quite measure, and he was able with some difficulty now, and he has multiple different tests where he's basically confirmed this, that he definitely has something there. These ultra small particles, which are definitely weakly interacting. The one thing I found that was neat about it, it's a power. They do tend to pair up, and it's paramagnetic, even though normal hydrogen isn't, which is neat because when everything, if you think about it as having spin to it, these almost have opposite spin, almost like little vortexes. Kind of one hand in this dimension, one hand in the other dimension, which really just screams of something that's close to an ether, like a transition particle between the ether and this dimension, the material realm. For me, there's so many different connections that make sense.
You're basically talking about an etheron when you that last statement, essentially.
Almost. I mean, maybe this isn't the exact thing, but it's getting closer. And there's multiple levels of it too, because he said there's according to Randy's theory, and it's pretty involved. And the one nice thing, he's only just down the road, and he's been in response with emails. I still owe him I've got a draft response. It's gotten pretty big of all the questions I want to ask him, kind of just to prime him for if I do get to meet him in person. But he's saying you can take any. So normally, if you look at hydrogen, they're saying, well, like standard physics would say, we have your n equals 1, n equals 2, kind of set quantized orbitals where it'll sit, and that's very well accepted. But what Randy's finding is that it can actually take these substates, and even Paul was a subscriber to this exact same notion that you can have a 1/2, a 1/3, even as low as, the fine structure constant is about 137. So it's that many different incremental levels at which you can drop, all of which you're releasing energy. So it just makes you, there's still a lot to be learned here. And I think the scientific community has been very resistant to this idea, as they are with most new discoveries, but I think there's something to it. I really do.
We're still recording this. You're okay with that? We're still recording this.
Yeah. If anybody else has got comments, we can jump in, or we can shut the recording off too here if we want.
Shall we shut down the recording?
Yeah.
Okay. Thank you, everyone. Thank you, everyone, for listening. I hope you have a wonderful day.
Yeah. Thank you. Yeah. Bye.
Cheers.